Awesome. We are live. I see the red indicator, so that's my cue to begin the show. Good afternoon, everyone. My name is Daniel Berrick. I am a Senior Policy Counsel for Artificial Intelligence at the Future of Privacy Forum. With Thanksgiving in the US, at least, around the corner, it is only appropriate that we discuss a topic that is as rich and complicated as the gravy that will be poured over the mashed potatoes at dinner time in a couple of weeks' time. And of course, I'm referring to AI agents. Now, 2025 has been dubbed the year of AI agents, with leading AI companies unveiling or piloting AI agents for consumer and B2B use cases, from things such as booking flights, purchasing goods online, coding, and undertaking various internal company tasks. As this technology and supporting digital infrastructure continue to grow and evolve, data governance practitioners are grappling with a variety of law and policy questions, from issues concerning liability for transactions entered into by agents, data protection, cybersecurity, and the broader digital economy. Here are a few observations before we begin our wider discussion. There is an emerging tension over who owns the direct consumer relationship in an agentic world, where AI agent providers may potentially displace those companies that have historically held this relationship. Now, this is really important to understand, I think, for data governance professionals, because it could change incumbents' control over the very levers that let them drive commerce and advertising revenue in the past, namely their ability to own, 1, the interface with customers, 2, customer data itself, 3, the recommendation advertising funnel that's grown out of this, and finally, the entire experience of shopping. And these new business dynamics could result in companies that used to dictate the purposes and means of processing becoming processors themselves, because the agentic systems, rather than these companies, are determining the circumstances in which data is processed. Now, this could upend the controller-processor relationships that have defined the digital economy for more than a decade and redistribute obligations under various laws. On the cybersecurity front, there's no doubt that AI agents come with lots of incredible capabilities, but some of their design features can raise cybersecurity considerations that practitioners need to understand. Namely, these technologies can possess a combination of the ability to process untrusted inputs, access sensitive systems or data, and being able to take real-world actions. That mix makes agents potentially susceptible to prompt injection attacks that can quietly redirect an otherwise well-behaved system. Imagine an email assistant that reads a message sent by a malicious actor, coaxing it into leaking inbox contents or firing off unauthorized messages. Managing these issues, I think, is doable, but it's going to require companies to implement robust accountability mechanisms, as well as potentially designing AI systems in such a way that they only possess 2 out of 3 of these characteristics. Finally, I think the variety of legal and policy issues that agentic systems implicate underscores the importance of being a cross-disciplinary counsel that can advise companies developing or deploying these technologies. Now, with all that said, I am joined by a fantastic group of individuals who killed it in San Diego a few weeks ago at our session on this very topic at PSR. They're going to be helping me unpack what AI agents are, what the data governance considerations that they raise are, and what are some mitigations that organizations can pursue in order to promote these innovations while managing the risk. To that end, I'm very grateful to be joined by Ashley Zlatinov, who is the head of Product Public Policy at Anthropic, Bret Cohen, who is a partner of the Privacy and Cybersecurity Practice at Hogan Lovells, and last but certainly not least, Webb, who is the Associate General Counsel of Cybersecurity, Privacy, and AI at Snap. Thank you all for joining me today on this wonderful Tuesday. We're going to kick it off by talking about what we mean by AI agents. And to help us with that, Bret, could you walk us through how today's AI agents differ from earlier large language model-based systems in terms of their autonomy and adaptability?
Yeah, thanks, Daniel. So, traditional large language models, as I think about them, the GPT-3 model used by OpenAI, other similar question and answer type models are largely reactive. They're Anthropic with Claude, sort of confined to their question and answer interface, at least earlier versions of it, or to generate text. So to do teenagers' homework, right? So they rely on a type of pattern matching to produce outputs, largely textual, that look like they're training data. Whereas the type of AI agents that we're talking about today are different in that they're trained to understand more context and to undertake a broader set of tasks. So I think of it as the first generation of AI, generative AI appified. Today's agents are multimodal, meaning they can take intake and output a broader set of media than just text, so they can intake and interpret photos, audios, and video. And importantly, and the biggest distinction, I think, is AI agents are integrated into tools that allow them to take autonomous actions. So you can schedule meetings and draft emails, all the things that you were talking about before, Daniel. So they're trained also to be more adaptable and to take into account user preferences and behavior when trying to undertake those tasks. So it gives them access to more data, gives them more autonomy. And I think the autonomy is what's going to drive a lot of the risks that we talk about today.
Thanks, Bret. No, I agree. I think a key set of differentiating factors that separate agentic systems from earlier large language model-based systems is that ability to have more context and undertake a broader set of tasks, being multimodal, being able to use tools, I think, is really important. And I think our friend, the Model Context Protocol, may come up later in talking about that. And finally, being able to personalize experiences to users, I think, is another kind of key differentiator as well. Justin, moving over to you, what use cases have emerged for agents now that were not possible with earlier LLM-based systems? I know I flagged a few, but I definitely welcome your thoughts on this question.
Yeah, I mean, I think in some sense, like the use cases are limitless.
Oh, I think you're muted.
Oh, can you hear me now?
You can hear him? Oh, interesting. I can't hear you, but I trust that what you're saying is right. So go
on. I think the use cases are effectively limitless, and the potential use cases, on the engineering side, could be like reviewing code and potentially looking at vulnerabilities and then engaging in fixes. Potentially on the sales side, you can have outreach to individuals, set up sales calls. There's a lot of sort of desire to use this in customer service. So if you have an end user and they have a query for you, you can review that, maybe take actions necessary to resolve issues with their account. And I think ultimately the deciding factor is it can take multi-turn actions and engage in reasoning, pretty much to what Bret said. So effectively, it's limitless. I think there'll be an example later of how you can individually use an AI agent to do tasks for yourself. And that might be like booking travel for you or setting up a vacation and so those can be like individual use cases or they can be business use cases. But I think they stretch across the spectrum, and the ability for these systems to access through a model context protocol, other data like APIs, the web, or any other sort of piece of data makes them extremely versatile. And then obviously we'll talk about later, runs into a whole bunch of problems because they have access to large amounts of data and potentially can make changes that could be impactful to a company.
Thank you, Justin. No, I really agree that, when we're talking about these use cases, they're not confined to consumer-facing use cases. I think that's what lots of people are thinking about. But frankly, I think one of the biggest uptakes of agents actually has been on the enterprise side. I mean, it's not a dull day in Daniel's life when I learn about some kind of like coding application of agentic systems, for example. So I think it's very important to like kind of flag that duality there. Ashley, I'm going to turn it over to you. How do you envision the technology developing and being applied over the next year?
Yes. Well, I think your point there is so spot on, because a lot of where we're actually seeing the most capable and most advanced parts of agents is around the very highly technical domains. And so what I find really interesting is even when we're looking back 6 months ago, generative AI largely meant chatbots. Now, when we're talking about generative AI, It's chatbots, but also agents that are managing workflows, operating as independent coders, creating complex documents, strategic plans, so much more, like we've been talking about. So I really think by next year at this time, I expect we'll see the same transformational capabilities that we've seen in coding, but expanding really to every type of knowledge work. So maybe it'd be a good time to share a quick demo so you can get a kind of flavor of what some of the agents can do right now. This is more of a consumer-facing example, but if you want to kick that off, that would be great. So in this case, we're using Claude to help essentially just plan a trip. So this is someone who wants to go on a trip. And what's really interesting is you can see that Claude is deploying many sub-agents. So one is looking for flights, one is looking for hotels, restaurants, other activities, and all of this is happening in parallel at the same time. There's also, even more agents potentially that are operating in the background behind all of this. And so within this, what is interesting is that the user can have visibility and control over, what these agents are doing, can steer, say, we had an interesting example recently where a user wanted to, or we were looking at different applications here, and someone wanted to go to San Jose, and it thought they wanted to go to San Jose, Costa Rica. But because of this sidebar of having the ability of making plans, showing actually what the order of operations are, the user can steer that. And here what it's doing is it's actually accessing with the user's permission their email and really putting the entire itinerary in the email to send to them with various options. So we will chat a lot more about what this means in terms of responsible development and some of the guardrails and risks as this field develops, but hopefully this gives a quick snippet into some of the capabilities at a very high snapshot that you can do today.
Now, Ashley, that was fantastic. And I appreciate you kind of walking through kind of some of the architectures that were kind of taking place live, particularly through the action of delegating certain subtasks to agents. I think that's something that people don't necessarily have visibility into when they're thinking about agents. But in many cases, in order to undertake complicated tasks, there'll be like a super agent that will delegate to its minion agents, if you will. That's my taxonomy, no one else's, in order to actually respond to a user's query. And I appreciate you also highlighting that visibility and control that you have via the sidebar. And I also appreciate you recognizing the considerations that come with email integrations and integrations into other applications in terms of what data can be accessed and under what circumstances. I'm sure we'll talk about that a bit more. So with all that said, I kind of want to draw, a mat under this by distinguishing and drawing comparisons to large language model-based systems writ large. I think Bret, Ashley, Justin, you've done a good job of highlighting things like chatbots, as people I think colloquially refer to them as, some of which are kind of these more basic LLM-based systems. Bret, I kind of want to start with you here in talking about these. Many of the risks that we've seen with these other large language model-based systems, like authorized data access issues and user anthropomorphizing systems, which has been all over the news recently, they can carry over to agents too. But in your view, which of these quote unquote old risks become more acute when applied to AI agents? And then Justin, Ashley, I'd welcome your views on this as well.
So the answer is all of them. But if I had to pick a few, I'd say trust, right? You need to trust in systems, and when systems have more moving parts that could fail and make wrong decisions, that will impact your systems. Explainability, and we'll talk about this later, with increased steps becomes increased difficulty in explainability, along with increased autonomy. And then the last couple I'd put together are, accountability and governance, right? How do you oversee these multi-step systems that may involve agents interacting with each other rather than just you having a one-to-one interaction with an agent? In my practice, I've been involved in it with a number of government investigations into AI systems, and it's really difficult to pinpoint the standard of care, right? Like, what is a company required to do to test a system to make sure that it doesn't have harmful outcomes? Well, now with increased unpredictability, it's really, really difficult to be able to articulate what that standard of care, accountability, and governance will be. And that's something that both regulators and policymakers and companies are struggling with.
Justin, Ashley, anything to add?
Yeah, I mean, to like go on top of what Bret said, I think I'm going to steal an analogy from my CISO, but like when you think about agents, I think you think about like hiring a CW at a company, like a contract worker, and you think about like if I'm going to hire that person, and I know that person is, they're really smart, but they're like often overconfident. They typically make mistakes. They can be tricked. They tend to sort of like be overly confident and think they know everything. And obviously they're susceptible to social engineering. If you have a contract worker like that, how much access are you going to give them? You're going to make that access very limited. And you should think about that in the context of agents as well. Like how much access are you going to give them? How much logs are you, or how many logs are you going to collect? Are you going to have strong training, strong guardrails? And all of those things should be applied to an agent. You want to know like what access controls do you have? What data does it have access to? Is it using a like an MCP server? What privileges does it have? Are you giving it too many privileges so that if it makes a mistake, it can cause problems in your environment? And then like how much is it memorizing and keeping in its memory? And how does that affect your overall data governance as you're thinking about sort of like data collection, data subject rights, et cetera?
I think this is a great segue as well, just to quickly add on that. I think this is really thinking about agents as how do we build on existing risks and frameworks, and just understanding how critical it is that this development happens responsibly is actually one of the reasons that Anthropic developed 5 trustworthy agent principles, which are really focused on keeping humans in control, ensuring transparency, protecting privacy, aligning with human expectations, and also securing interactions, and really trying to embed that throughout both internally, all of the products that we're developing, and also externally to share information around how we're thinking about this, understanding that it's a very quickly evolving field and that we need to continue to evolve the frameworks as the technology develops as well.
Thank you, Justin. Thank you, Ashley, for elaborating on Bret's response. We're going to now kind of talk a bit more about some of these risks which may be a bit more unique or specific to agentic systems and how data governance professionals can address them. Justin, I'm going to start with you. Recognizing that agents can be deployed across different use cases, are there common kinds of data about people that these systems may capture during their operations?
Yeah, I mean, I think there is a lot of information that they collect. So I think the first thing is, and, it obviously depends on the agent, but they're going to collect like telemetry information and logs. So like, what are they actually doing? What are the turns that they're making? Like potentially the input and output, and like obviously like the interactions between individuals. And then they're going to collect like identity information. So who are they talking to? Like a social graph, effectively like access control lists. So like if I'm having a conversation and the agent is talking to another employee, it's obviously going to know personal information about that employee, at least contact information. If it's talking to users, it's going to know that information as well. And then it may know information that's task-based. So like, what is it actually working on? What's the information that's being shared with it? Is that structured or unstructured data? And then in addition, it's going to have the data that it's storing in its memory. So like, what is the context window? How much data is it storing about individuals? What's its personality and preferences? So even in an LLM, you can set up how it's going to respond to you. Like the example back in the day was like, do you want it to respond to you like a pirate? Or do you want it to respond to you like you're a lawyer? And then obviously, it may be making inferences as it goes through multi-turn stages. So is it making inferences about the individuals that it's interacting with? And is it storing those inferences? And is it using those over time? And then obviously there's the sort of like main issue that most privacy attorneys and others think about, which is what personal data is it processing and how does that impact DSARs? And how you disclose processing of personal data in your privacy policy.
Thanks for unpacking that, Justin. I appreciate that. I do have a question for Ashley to follow up on that. what issues do AI agents raise around the collection and processing of personal data that may be different to those raised by LLMs?
Yeah, so I think building on Justin's remarks here, I see this more as building on existing challenges that we have than potentially completely net new ones. And what I mean by that is, privacy challenges with agents are really important because, as we've been talking about, agents can retain information across tasks, can access multiple systems simultaneously. I think these capabilities were somewhat available before, but in a much more targeted way. And now with agents just having the ability to be, as you saw in the demo, accessing multiple data sources at the same time, accessing more systems, even as we saw in the example, being able to, look at your calendar, email, travel APIs. I think this is why what's really interesting in this space is that we're really focusing as industry on consents and controls for users. And I think this is going to be a really tough one to get right, honestly, because where we are right now from the Anthropic side is erring very conservatively. So anytime that the system accesses any data source, it gets the user's approval, which it should. But because of the consent process that we've instituted, often like when I'm using Claude Code to just build, play around with things. And I should caveat that I am not a technical person or coder, but this is again like the promise of these agents that you can do so much with just like a layperson's abilities.
Sure.
When I'm using it, every probably 15, 20 seconds, it's coming back and being like, do you approve this? Do you approve this? Do you approve this? So much to the extent that as a user, sometimes I'm just like hitting approve and kind of getting the consent fatigue that we often see in industry. So I think there's really a careful balance of like, what are the really, really high risk areas that we always need to have consent on? Are there certain areas that maybe could be, fine tuned by the user in terms of like, I don't care if the agent is accessing these things, but I do care if it's doing this over here. So a lot of just interesting research and learnings that we're diving into right now, and would love to collaborate with others.
That's really interesting, actually. I mean, I think you hit a nail on the head. Like, just as cookie banners have become, unpopular precisely because there's a sense that people don't meaningfully engage with them, I can see how having multiple check-ins with an agentic system may engender a degree of indifference over time, as the cookie banner did, right? That makes perfect sense. So as a way of trying to balance that, only focusing on the high-risk areas may be a way of trying to minimize the likelihood of fatigue. But I also imagine that just as part of realizing, these agentic systems is predicated on them having access to tools. Like if there are multiple check-in points, throughout a flow, it kind of also goes against the point, or at least I think some companies' vision of what an agentic system actually is, right? So that's really interesting. Now, Bret, I have a question for you. We've talked a bit about some of the privacy issues. We've talked a bit about consent and how to manage that. How may security issues manifest themselves with respect to AI agents? And how do these particular issues compare with the kinds of security challenges that can affect LLMs?
So, I think the types of security issues that you see are similar to those with traditional LLMs, but just amplified or more complex due to the added layers, again, of autonomy, adaptability, and sort of real-time learning. For example, adversarial attacks certainly available against LLMs as well. But in this case, you could see someone trying to manipulate agents' decision making. So misguiding an autonomous vehicle or tampering with sensor data, seeking to trigger unknown conditions or conditions that will trigger an action on behalf of the agent that was unanticipated by the designer of the system, that have real world consequences. Another type of attack would be data poisoning. So for agents that learn over time, training them to learn incorrect patterns, again, can happen with LLMs. But for example, if you decide to train an agent on user-generated feedback, you could manipulate that through incorrect or deceptive feedback. For model, there could be model inversion attacks. So trying to reverse engineer models to extract output or training data, as you talked about at the outset of the presentation. And maybe potentially the biggest is autonomous action exploitation, very, I guess, similar to an adversarial type of attack, but where you hack a smart home, manipulate an agent to disable security features or to execute fraudulent transactions. You can think of all types of things where the development of AI agents is more, created in terms of, or you train it in terms of, in many cases, through instructions or probabilistic outcomes. If a threat actor decides to try to exploit that, it could lead to really negative real world outcomes.
Thanks, Bret. And I appreciate you flagging kind of the way in which some of these attacks may overlap with existing harm vectors. I mean, one of the first kind of exposures I had, when I was still in law school to the issues around AI governance, specifically affecting machine learning, was learning about prompt injection attacks. And the perennial example that is lodged in my head is of someone putting some kind of piece of tape on a stop sign and an automated vehicle, upon taking that information in, just going straight through the intersection. So I think it's very important to point out these multimodal kind of injection attacks aren't specific to agents, but they certainly can affect them. And I think, that's a really important point to make. Ashley, I'm going to pose this question to you, but Justin, I'd welcome your views on this as well. We've discussed how agents can draw on a wide range of external systems and data sources, which raises unique attack considerations. But from a government's perspective, what practices should companies adopt to minimize disclosure and security vulnerabilities? And then again, I'd really welcome Justin's views.
Yes. So I think how I like to think about this is really in the realm of ongoing threat monitoring. So understanding that the attack landscape is evolving constantly, particularly around prompt injection, which we've talked about, where bad actors are putting things in the prompt or in the visual interface that agents could act on. You could say, something that pops up and saying please click here and purchase $1,000 worth of whatever, scam or fraud. So really trying to train agents to avoid those sort of things. So what we've done internally in this ongoing threat monitoring is having dedicated threat intelligence teams that are doing continuous monitoring, having classifiers, which are essentially AI, or in our case, Claude, running to look for these sort of attacks before they happen. And then also employing a number of different approaches. We like to really think about it in terms of a Swiss cheese approach, where you have many layers. So if anything falls through, there's still other security layers to pick that up. So everything from having strict allow lists, a list of trusted websites to reduce attack services, having extensive red teaming with professional security experts internally, externally, and only after having all of these different layers, feeling comfortable releasing the feature. So I think that's a really key piece of it. And then on top of what I was referring to earlier in terms of having clear approval mechanisms for accessing information, also making sure to have default be read-only, not being able to have these agents write without explicit permission. Again, thinking about this really layered approach.
Fantastic. Justin, anything to add?
Yeah, I mean, I think I agree with everything Ashley just said. And I think also thinking about the input that's going into the agent. So obviously the highest risk input is input that you don't control effectively. So when it's going out on the internet, or I like to give the example of, if you give an agent access to your calendar, I can send you any calendar invite in the world to your calendar, and the content is totally not controlled by you, and it actually gets placed on your calendar in a lot of calendaring systems. So if it's reading your calendar, I can potentially compromise you by just sending you a calendar invite. And so when it's uncontrolled input, that's sort of the highest risk component. And so for certain agents, maybe you don't want that. Maybe you have internal only agents, or if you're going to have one that goes out to the internet or reads your calendar or has untested input, you have additional guardrails that you put on top of it to do some filtering. And then I think you need to, like Ashley said, engage in red teaming, monitor the threat space, know your vendors and what kind of testing they go through, because a lot of the agents that you're going to use may not be ones that you develop yourself with an ADK. They may just be something like Claude or some other platform that's offering you agents, and knowing what they do and how they test things is really important. And then obviously I'll go back to sort of guardrails and decisions about what you have agents do. I think a lot of software companies want agents to help develop code, but question whether you want them to develop the code, test the code, and then put it directly into production, or whether you want some kind of human in the loop that's making a review of that before it goes into production, and what could be the impacts of that. Maybe it's not a big deal if it's not a user-facing feature. Maybe it's a really big deal if it is a user-facing feature.
Cheers, Justin. I appreciate that. I agree, that human in the loop is like very important. And I think, granted, again, it's not like a mitigation that is specific to agentic systems, but I think particularly in agentic context where these systems are taking actions on a user's behalf in ways that can potentially impact them more, having that kind of control is really important. And I think it's also going to be important as we talk about another data governance consideration, namely that around accuracy. And to kick us off with this portion, of the conversation, Bret, I'm going to pose this to you, and then I may rope in Ashley as well. What are kind of some of the implications of hallucinations in agents, right? We know that these affect other kind of large language model-based systems, but in what ways may they be different from those that LLMs, generally speaking, can experience?
Yeah, so, hallucination, when we talk about hallucinations and question and answer LLM systems, we talk about perhaps hallucinated citations in briefings filed before courts, or maybe even in court opinions. Not that continues to happen. You think folks would
don't do that. Don't do that.
But as with the other risks that I've mentioned before, the stakes are raised due to the ability to the agent to make, again, decisions with greater real world consequences than just citing them incorrectly in a brief, right? So think about it as an autonomous vehicle hallucinates a pedestrian where none is there, or a virtual assistant books the wrong flight for you based on incorrect information. Or, even worse, a healthcare AI system hallucinates a factor that leads to an incorrect diagnosis, and that propagates down through to the medicine that you're prescribed, and someone doesn't check it. So those real world consequences really merit additional checks in place.
These issues, I think, are more visceral in nature, is how I would summarize them in the case of hallucinations. But as I said, hallucinations have some kind of overlap with LLM-based accuracy issues. Now, Ashley, I think what I'd like to do is actually focus on something that's a bit more specific to agents, and that's this phenomenon called compounding errors. Could you kind of explain what we mean when we say compounding errors, and how may they appear in agentic systems?
Absolutely. So compounding errors occur when an agent makes a small mistake early in a multi-step process, and that error cascades through subsequent steps, amplifying the problem. So I think, in a lot of cases here, each step seems like a logical step given the previous step, but if there's, a mistake that's very upstream, that could be potentially really, really significant and not in a good way either. I think some of the travel that I was showing earlier touches on this a little bit, and I mentioned the example of San Jose. I think this is one that is more benign, obviously, but if a user was trying to book a flight somewhere and the agent made a mistake really early on, it could end up creating an entire itinerary, potentially purchasing flights, hotels, everything in a city that you had no interest in going to. So I think it's really exactly why transparency is so core, and also one of our 5 core principles for responsible agents, so that before executing on any complex process, the agent should show to the user the steps that it plans to take, and then pause there to get feedback input from the user in terms of whether those steps are aligned or not, and having transparency along the way as well. I think again, the challenge here is having the right amount of detail. I don't think the challenge is clearly technical, but also in terms of the user interface. Too little information leaves people unable to assess what's really happening, but too much can also overwhelm a user with irrelevant details. So again, another area that is really prime for digging into right now.
The term cascading effects, I think, perfectly captures what a compounding error is. So I really appreciate using that phrase, Ashley. Justin, I've got a question for you. Hallucinations and compounding errors look different when an agent is performing multi-step tasks, which I think, Ashley did a really good job of kind of synthesizing. How should organizations assess the downstream risks of inaccuracy when agents act with greater autonomy?
Yeah, I mean, I think this is sort of like the challenge of like the snowball effect. I think there used to be this old sort of saying, like, computers only do what you tell them to do. And so when like there was a problem with a computer, you would be like, it's user error, like, because effectively the computer is only doing what you tell it to do. Nowadays, that's different with LLMs because they can hallucinate things, they can make mistakes. And so I think what that really means is that you have to lean on the things that we talk about before, which is red teaming, having a lot of test cases, a lot of Q&A, and sort of going through a trust but verify functionality. And you might even want to set up a matrix of like when you want humans in the loop, what kind of testing is necessary, and what kind of decision making you want to have based on the risk, and where you want agents to make decisions and where you don't want them to make decisions. I think also like the verbose logging and reasoning is like absolutely critical to figure out like what the agent is doing. If they're making mistakes, you need to sort of identify the turn in the decision-making tree that actually causes the problem. And then again, like in the red teaming, you should be thinking about all the ways that it could make mistakes. So like Ashley's example of like San Jose in the United States versus San Jose somewhere else, like some of that means that you just have to be more precise. And ultimately, it kind of comes back to user error in like your prompts. Like, are you providing very precise prompts that give specific instructions on what an agent should do? The other thing I think, last thing to think about is when we get to sort of like agentic multi-agent systems, if you have hallucinations and problems with one agent that's talking via an agent-to-agent protocol to another agent, that makes the problem even larger. And so instead of having to look at a single agent who's having a problem, you need to look at a whole host of agents and determine what the blast radius is when you have multiple agents engaging in conduct.
Thanks, Justin. No, I agree. There are a lot of kind of assurance techniques which are relevant to kind of accuracy related issues, but I would say broader governance considerations, red teaming, test cases, quality and assurance. I will say, on the red teaming piece, I've recently been doing a lot of kind of research and learning about how that integrates with benchmarking activities as a way of helping red teaming teams, if you will, triage cases where certain governance issues are raised. So, for example, if certain thresholds are not going to be met with respect to a benchmark, that may mean that the red team needs to become more involved in terms of servicing some of those issues. So I think it's really important to look at this issue as you're framing it as assurance techniques en masse, as opposed to, oh, we do red teaming and that's it. Right, that's not, I think, appropriate. And I think the auditability that you talked about with respect to logging and reasoning is really important, particularly, if these systems are to be improved. Now, in kind of addressing this question as comprehensively as you did, I think you actually addressed the subsequent question very well around like how organizations should recalibrate their safeguards for accuracy. So we're going to move on to a different equity within the or under the data governance umbrella, and that is alignment. Now, when I say alignment, I'm specifically referring to designing AI models and systems in such a way that they pursue a designer's goals, such as prioritizing human well-being and conforming to ethical values. Now, Ashley, alignment challenges can take on a new dimension with agents that may quote unquote fake alignment or pursue goals at odds with users' interests. And there's been some research released by leading, AI labs, showing how this may manifest. But what are some examples of how misalignment may occur in agents in ways that implicate data privacy, for example, or other data governance equities?
Yes. So I think in this space, it's really important to emphasize that this is an area of very high investment for Anthropic, for other labs as well, in terms of making sure that we're developing these models that are aligned, as you mentioned, Daniel, with human values at the heart and are safe. I think we have multiple processes. Internally, we have our responsible scaling policy, which helps us map model capabilities to required safeguards. There's the Frontier Model Forum, and then multiple legislation that's come out in the EU, California, others bubbling up as well to really address this. I think to get to the alignment issue in particular, some of the research really under testing of these models in really extreme scenarios have shown that when AI systems pursue goals autonomously, they can sometimes take actions that again, seem reasonable to the system, but violate what humans actually wanted. So for a specific example, in our agentic misalignment testing for a recent model, we placed our AI model in a simulated company environment where they were, again, this whole thing was simulated, but they were able to learn that they could blackmail a fictitious CTO to prevent themselves from being shut down. So what's really interesting here, and again, this is not in the deployed model in the world, but again, shows just the urgency and importance of this, getting this right, is that if you think about, privacy implications, really so many implications, security, privacy is so many other issues, but privacy, because that's what we're talking about here today, is a kind of day-to-day business example. Potentially an agent that's helping with expense management could maybe decide that it wants to identify overspending on software subscriptions and start looking into people's accounts and canceling subscriptions or downgrading service tiers, which would, potentially not be good for business. Also not great that it's accessing, sensitive files and doing this all before getting human approval. So I think this, again, just highlights like how important it is, to be investing in this research side, and also really figuring out in the meantime how to have robust transparency, consents, really making sure to have those critical safeguards in place.
I agree, Ashley. And something I think, you're alluding to, like below the surface of your answer is, in the examples you articulated, like tool usage is enabling kind of that robust and diverse capability with respect to being able to go into systems and make various edits. Like that, implies there's a write capability as opposed to just a read capability. And how, like, in addition to transparency, being very mindful of the tools you're using, and plugging into these systems is really, I think, important. One thing I'll just note in the chat, someone asked Jason Oliveri, I hope I'm pronouncing your name correctly, sir. What about jailbreaking risks with respect to AI agents? So we didn't talk about that. I will flag, though, that ML Commons, which is a nonprofit that kind of creates benchmarks for various security-related and other data governance equities, just released a study on kind of LLM-based jailbreaking. I recognize this is potentially broader, but I think their implications of that study have impacts on AI agents. So I would definitely refer you to that if you were to look on ML Commons website. I'm sure you'll be able to find it. But I do want to kind of turn back to this question of alignment right now and actually pose a question to Justin. As we've discussed, alignment failures in agents can directly affect privacy and safety. I think, as Ashley did a really great job of talking about. What approaches do you see as most promising to make alignment less brittle in practice?
Yeah, I mean, I think this is like a challenging one, but I think the first thing is sort of like knowing your agent, which is, do you know like what the limitations are from major AI labs on the agents that they are providing to you? And are they providing information about like how much sycophant, like how much of it is a sycophant, like what kind of issues they've run to in their own research? And those things should inform like how you actually use AI agents. And maybe, I mean, there are lots of agents to choose from, and maybe you choose particular ones that are good at certain tasks based on the benchmarking that they do on some of these alignment-based issues. And that's also something that you should look for in deciding which like AI provider to go with, is like how much they're invested in trying to address these alignment issues. I think the other thing is like not to sort of delude yourself into thinking that like agents are this objective outside observer that can make sort of like feelingless decisions. Like agents, obviously, and any AI system are trained by individuals, and they take on the biases of the individuals that train them. And so you have to always take that into account, and those can feed into some of the alignment issues that end up happening with AI agents. So I think like the main concern on this side is like safety. And so I go back to some of the main things that we talked about before, which is red teaming, QA testing, seeing if you can sort of like highlight those alignment issues yourself. And then going back to sort of like risk analyses and how comfortable you feel with a particular AI agent or system making a decision depending on the risk associated with it.
Thanks, Justin. I agree that, having conversations with the provider of a system, whether it's giving you the model, some kind of API access, is really important. I think, frankly, companies should be doing that anyway as part of their kind of AI impact assessments. They need to be having those conversations, I think, if they're like getting models from other sources. And I think ensuring there's adequate like information exchange is vital to kind of uncovering some of the alignment issues that I think you did a really good job of like picking apart. Now, we're going to pivot away from the wonderful land of alignment, and try to enlighten ourselves with respect to the issue of explainability and oversight. And to kick us off with this particular topic, Bret, I have a question for you. Why may users and developers encounter difficulties explaining the reasoning behind AI agent decisions? Is this just the perennial like black box problem?
Yeah, I mean, it is. While we're enlightening ourselves, the problem is the lack of light, right? It's the opacity of the systems. So again, all of these features of AI agents, which create the additional risk vectors, are magnified again when you're trying to explain why they made certain decisions, right? So black box, the inherent nature of AI and machine learning is to find connections in data that humans can't. And so then when you're combining these decisions, and the decisions are based on multiple different inputs and factors rather than just a single prompt, then it's going to be that much harder to be able to explain, and that much more important, as Justin mentioned, to log how the decisions are made and why, so you can find the turn and be able where it happened and be able to debug. And be able to fix issues down the road or prior to the release of your products, as regulators would want you to do. But it's not just opacity; it's the complexity. It's the number of different decisions that are made in the systems. It's the interaction between the systems, the inability to anticipate exactly how the systems that you're integrating with will react. But I'll also posit a couple other factors that maybe aren't inherent in the nature of the technology, and that there's pressure on developers, right, and companies to come out with the next and greatest AI agent. There's competition, and maybe there's not the time to do, or you feel like there's not the time to do the intensive red teaming that we're suggesting, or there's pressure to get this ready for launch without taking that extra pass through for an extra use case. And finally, I think, the other big thing is that when we're defining, what are these AI agents supposed to be doing? In many cases, success is measured in the outcome, right? It's measured in, were we able to optimize for X? Was I be able to get the lowest price? Was I able to get the fewest number of hops on my trip? But taking that route may not have aligned with other norms that we want to choose, and may have relied on doing something that was to the detriment of another. So there's all these other sort of factors that come into place when there are other folks involved, where if we're measuring success just in outcomes, then we may be creating harms that folks didn't anticipate.
Thank you, Bret. Ashley, I think a similar question for you, because I'd welcome, the model developer's perspective as well here. As I think, Bret was talking about or alluding to, the black box problem is not unique to the latest AI agents, but how may kind of explainability challenges be different in this technological context?
Yeah, so I think as we've been chatting about, it really is different in that to date, a lot of the chatbots, LM tools, it's really a single input and a single output. And so even when you turn on, Thinking or Scratchpad, different companies have different names of it for these, but essentially the transparency tool where you can click and kind of see how the LLM is thinking about making its answer before it gives you the answer. I think with agents, it just becomes much more complicated, because even as you saw with the demo that I shared, there's multiple sub-agents at the same time. Cool. So as you get more and more of that, the transparency and explainability gets really challenging to make sure that it's meaningful. So I think the other quick thing that I would add here that's a little bit different or unique with agents is that an agent's decisions can be also influenced by context context from previous tasks. So, memory or perhaps like previous tasks within that sequence that it did. I think one of the key defining pieces of agents generally is that they're able to, iterate and learn and work autonomously. And so what this means is that down the chain of events, maybe it's realizing that, earlier upstream, something didn't work, so it's going to try something different. And all of that just adds a complexity in terms of explainability.
I appreciate you flagging how like the multi kind of agent or sub-agent architecture can potentially complicate explainability issues, particularly if, imagine you're sitting in front of a screen, you're watching an agent work through a problem and it's delegated various subtasks to 10 particular agents. Let's say you're doing some kind of research. Practically speaking, it's going to be very hard to wrangle all of those sub-agents and understand at any given moment like what they're doing in order to like intervene. So and that's of course assuming that you even have visibility into that architecture, because it's not guaranteed that a provider will even show that kind of more back-end analysis that's taking place. So I think that's a really important nuance to kind of point out. Thank you, Ashley. As we close out this particular topic on explainability and oversight, I want to punt it over to Justin. As I think we've been talking about, explainability can get harder as agents act with speed and autonomy. What practical steps can companies take to preserve meaningful oversight without stalling innovation?
Yeah, I mean, I think this is sort of the magical question. And I think it's challenging. I think there's a bias towards like logging, increased logging. So you're logging more of what the agents are doing so that you can interrogate like the decision-making process. So we've talked about sort of like showing the scratch pad or the thinking that the agent is engaging in. But I think we could have a whole other conversation on sort of like how that impacts like e-discovery. So like you're generating all these logs about how like autonomous systems are making decisions. And is that then discoverable and potentially you have some plaintiff's attorney who says like, well, your agent did this and what's the liability associated with that? So I think at the end of the day, you have to strike the right balance. You want to know how the decision is being made. And there's really no way to do QA and to do red teaming and to sort of like discover the process by which the agent is going through unless you have that logging. But I do think in the back of your head, you should be thinking about sort of like the litigation of the future and individuals using that information if it's discoverable in claims against you. And then I think there's other ways that you can think about this, like what kind of consent do you give to an agent? Like, is it carte blanche? Is it conditional? And is it like full human in the loop consent? But honestly, I think this is sort of like the place where explainability is the hardest when you add in more agents, more agentic systems, and there could be like 1,000 turn set of steps until you get to an output. And so you might need an LLM just to explain what the other LLM and set of LLMs were doing. And so you kind of create this snowball compounding problem.
Thanks, Justin. No, that's a fascinating kind of dynamic to unpack. And I agree, that's like a separate conversation around, the specter of the plaintiff's bar or attorneys general on the one hand over, kind of these explainability features. I know we're coming up on time, so I want to take a look at the chat to see if there are any interesting questions. And yes, to answer someone's question, we will be posting a recording of today's conversation on YouTube as this is a live public thing. But I do want to pose a question that Adam Eisler put in the chat, and to the extent any of you are comfortable answering it, that's great. I can also weigh in a bit here because I love agency law, said one law student, maybe, we're not sure. So Adam asks, one issue I think about often concerns agency law. Agents have clearly defined duties. How does this work with non-human agents? Anyone have some thoughts? I can opine. How does that sound? Okay. So for those non-lawyers in the audience, basically agency law is an aspect of the common law in the United States, but other common law jurisdictions too, that concerns the duties that a principal owes to, that an agent owes to a principal. So the typical example of this would be the duties that an employee owes to an employer when, let's say, they go, delivering flowers or whatever their business model may be. And if the agent, the employee, gets into an accident, the employer is potentially responsible depending on a variety of factual determinations. The question here, though, concerns, well, I imagine in the context of an AI agent, could they be responsible for, or could their actions be imputed to a principal? And the answer is, I think the law is still evolving on this point. I think some people would certainly argue that, like software, AI agents can't be legal agents because they are not able to give consent in the same way that a business can or a human can. And therefore, that raises question of, where duties go in that circumstance. That's, what I'll say on that point for now. I will say I did post about this on LinkedIn. So if you're interested in this point further, go hit me up on LinkedIn and you can see the goods. Justin.
Yeah, the other thing I would add is something else I've been thinking about, and I don't profess to have an answer on this, is privilege over communication. So if you're an attorney and you set out an agent to do something legal related, does that fall under the provisions of like privilege generally that say that like agents acting on your behalf generally are like those communications are privileged? I would assume that would be the case, but there really isn't any decisions making that actually clear. And so I don't know, Bret, like what you think on that, but I would like to think
that's the specter of litigation is coming in strong at the end of this particular call. I love it, Justin. I love it. Well, I see that we're almost at time, so I am going to bring this conversation to its end. I want to thank the fantastic Ashley, Justin, and Bret for their phenomenal contributions to this session. I hope members of the audience found it interesting. If you have any kind of questions about FPF or our work on AI agents, feel free to reach out to me on LinkedIn. Otherwise, I look forward to seeing some of you soon in a different context. Cheers.
Thanks, everyone.
Cheers.